Hi everyone, let's solve this problem unique paths. There is a robot on an m cross n grid. The robot is initially located at the top left corner, that is grid 0 0. The robot tries to move to the bottom right corner, grid m-1 n-1. The robot can only move either down or right at any given point of time. Given the two integers m and n, return the number of possible unique paths that the robot can take to reach the bottom right corner. The test cases are generated so that the answer will be less than or equal to 10 into 10, 2 into 10 power 9. So let's check this. So in this case, if I am at this particular cell, I can move towards the bottom or towards the right. That's what they are saying. So what are we going to do is, basically we are going to start at the bottom and at the finish line, and number of unique paths to reach from that cell to itself is nothing but 1. And now, so obviously there will be boundary cells and these are out of boundaries. So just to ensure that you understand, I'm just making sure that all of them are zeros, though we are not going to use them. So all of them will be surrounded by zeros. So now in this case, if I have to calculate the answer for this, I know that there is no bottom cell, so I'm just going to take the cell from the answer from the right, and at any given point of time, let's consider this as ij. The bottom will be I plus 1j and towards the right will be I comma j plus 1. So the answer at this particular value is nothing but dp of ij will be equal to dp of I and j plus 1 plus dp of I plus 1 comma j. But if you observe at the bottom, boundary cells will all have zeros, so all of these values will be just ones because the values are going to come from just right cells. So if you see here, it is 1 and there is no bottom. So if I'm calculating for this particular cell, bottom is 0, right is 1, and if I'm calculating for this cell, bottom is 0, right is 1. So all the values will be 1. Same thing happens with this particular column as well. All of them will be 1 because I'm getting the value only from the bottom, and all the right cells will have value 0. Now we are going to calculate for this cell. Now this has values which can be filled with the combination of bottom and the right. So it is nothing but 2. Now again bottom and right 3, bottom and right 4, bottom and right 5, bottom and right 6, bottom and right 7. Again we will go to this particular cell, bottom and right 3, bottom and right 6, bottom and right 10, bottom and right 60, sorry, it should be 15 because this is 10 and 5, and bottom and right 21 and bottom and right 28. So the answer is 28 and the answer lies in dp of 0 comma 0. So this is how we are going to get the answer. So now let's write the code for this. So first let's define the dp array. So we are going to define an array of m and then array of n dot fill. All of them initially will be filled with zeros, and then we are going to iterate from I is equals to m minus 1, I greater than or equal to 0, I minus minus, and then for let j is equals to n minus 1, j is greater than or equal to 0, j minus minus. Now if it's a boundary cell, that is nothing but if I is equals to m minus 1 or j is equals to n minus 1, in this case what should happen is dp of ij should be directly filled with 1 and we just have to continue from here. So this is the case where we are filling ones at the boundary row and boundary column. Now once this is done, we kind of calculate the bottom value is nothing but, so if I plus 1 is less than m, in this case I'll get dp of I plus 1 j, otherwise the value will be 0 because it will be out of bounds, and then right value right value will nothing but j plus 1 is less than n. In this case we will get dp of I j plus 1, else we are going to default it to 0. And now dp of I j will be bottom value plus right value. So, and towards the end of it we are going to return dp of 0 and 0. That is where the answer will lie. So let's try to run this code. Let's submit it. And now let's also understand the time and space complexity of the solution. Time complexity is big of m cross n, because we are kind of iterating over m all rows and n all column cells, so it will be big of m cross n. And the space complexity is big of m cross n, because we kind of are creating a dp array which is of size big of m cross n. So I hope the solution is clear. Thank you.